Now you don't need to write this part, it's just sort of an introduction. It's just saying that algebra, the point of algebra, if you haven't picked it up by this stage, is actually to make things easier. Okay? Modeling things with algebra makes it much easier to do. It gives a general case for things that we can then use in all sorts of specific situations. That's the point of it. So instead of working out for a whole lot of different sets of values, we use variables, okay, which are these letters, so like things like x, y, a, b, g for gravity, or whatever it might be. And we use those instead of specific numbers. And then we say, well, in this particular case, the rule is ... expressed in variables. Okay? So for example, you have an area of a rectangle, you've got length and breadth. So we can say that for any rectangle, the area is LB, length times breadth. Now, that's a general case, and so you can say that for any rectangle, I can just substitute in the length and the breadth, and it can become that. Or, instead of working out the average of three numbers all the time and thinking it through each time, if we have average x of three numbers a, b, and c, x is equal to a plus b plus c over 3. Right? And so that's the way, that's a general rule using algebra to do it. That's a simple sort of simple example, but gives you an idea of the point of algebra. Now, an algebraic expression is just something that has variables involved. Okay, 3x, 4y minus 3 or something like that. Okay, but I expect that many of you, all of you have seen this before, familiar with these ideas that are gone. But you have had trouble in the past understanding. We have some time now for you to either go over it quickly and then do some other things, or to spend some time doing it now and grasping it a little bit better. Okay? So you've got an opportunity to do that. So don't worry too much about this stuff, it's more just examples. So, simplifying algebraic expressions, we can only add or subtract what we call like terms. Like terms that one underline. Okay, you can only add or subtract like terms. Which means that you have to know what like terms actually are. Can anyone describe to me what they think? What is a like term as it comes up on the screen? Yeah, so excellent. So the definition is, yeah. Okay, so it has to be the same variable to the same power. Same combination of variables to the same power. Okay? So you can have x and 2x are like terms because the x's are like. 4dA and 5ad are like terms. The combination's the same. The order doesn't matter. X squared y and 6y x squared are like terms. Again, you've got x to the power of 2. You've got y just by itself, no power, but to the power of 1. And the order is different, but they're like terms. So you can add or subtract. You have 6 lots of one, you have 1 lot of the other. X and x squared are not like terms because the powers are different. Okay? The variable is the same, but the power is different, so it actually makes it a completely different thing. Okay, you can't really say that 3 is the same as 3 squared. 3 squared is 9. It's a completely different thing, whereas 3 is different. Well, 4a and 4ab are not like terms. They both have 4a in them, they both have a variable a, but this one has b. So the combination has to be exactly the same. Right? Same combination of variables, each of them to the same power. The order can be different if they are multiplied together, but it has to be exactly the same. Right? And then you can have how many numbers before it doesn't matter. It's called the coefficient. The coefficient of the term doesn't matter. It's simply the variable, the combination, and the powers of them. Important idea, make sure that we grasp things. So to have some examples, simplify the following expression. We have 5x minus 2y plus 3y minus 7x. Which ones are like terms, Alex? Good. So we can actually rearrange this if you wanted to. 5x minus 7x minus 2y plus 3y. Now, how do I simplify this? What's 5x minus 7x? Yeah, minus 2 lots of x. We have 5 lots of x, take away 7 lots, minus 2x. What's minus 2y plus 3y? Just y. That's not minus 1. You think of minus 2 plus 3 is positive 1. So it's plus y. Or we can rearrange it as y minus 2x. If the order doesn't matter when you're adding and subtracting, you can rearrange it. And this adds to an interesting point that again we need to be taking note of, which says that the sign before the term belongs to that term. Okay, this is 5x, this is positive. This one's negative 2y. It's always negative 2y. Whether you rearrange it and move it around, this negative sign sticks with this term. Because it's not positive 2y, it's negative 2. Okay, it's a distinct difference. This negative sign sticks with 7x, and this positive sign sticks with the 3y. So we need to be careful that you're doing the operations correctly. So in this case, it's not 2y plus 3y. It's not as if there's brackets here. That's not the way it is. You're saying that it's minus 2y plus 3, which is positive. Okay? 6ad squared plus 3ad minus 5d plus 2d squared a minus 3d. Basic. What are the like terms here? Sorry? 6ad squared. What's like with this one? There is. This one is a like term. Alright, 6ad squared is like with 2d squared a. Because the d is squared, the a isn't. So they're like terms. And so 6ad, that's going to be 8ad squared. Alright, what about 3ad? Are there any like terms with 3ad, Brandon? Which one? 3dA. So what happens? 3ad minus 3dA? What is that? Sure. Take away something. 3dA and 3dA are the same. You're subtracting them from each other. What do you get? Nothing. You get 0. Okay, so you're just taking it off. And then the last one is minus 5d, but that is just by itself. There's no like terms in minus 5d. Alright, so we need to be as careful to make sure we identify what like terms are. Thinking about when you take something that's the same, when you take itself away, it goes to 0. Just because there's variables involved doesn't just go to go 1 or whatever it might be. It will go to 0. Okay? And the final one, find the perimeter of this triangle in terms of x and y. What kind of triangle is this, Harrison? Isosceles, which means that this side is what? Yes. Okay? So if we add up the three sides, what are we going to get? P for perimeter is equal to, well, that's the angles. Yeah, we're not adding angles. We're just adding the side. So we've got 5x minus y plus the other side, which is 5x minus y plus x plus 2y. Right, tell us. We simplify this expression.
And x.
Sure.
And then you get rid of the y because there's squared here.
Yeah, so minus y plus 2, that cancels out. Good. How many lots of x are there?
Oh, no, you don't because you got rid of that y. So
Got 5x plus 5x plus x. 11. Good. Alright, 11 lots of x. So that's what we do when we add like terms. Be careful to know what like terms are and doing it. Now, we do this exercise. Each question, every second part. There's no hard and fast rule. I just want you to do enough and go over things that you feel comfortable doing. Okay, I'm going to stop you in a little while and go over something else. But take care to revise the things that you need to revise. Some people here might have to do all the questions to get familiar. Others may not. But don't think, oh, I know this. Please look through it carefully and think about what sort of things do I need to be taking care of. Making sure that I get and understand. Okay? So it's on your sheet that I gave you.